Yeah. Can you guys confirm is my screen visible?
Yes, we are able to see your Internet of Things.
Okay. So hello all. Welcome to the session. So in this session particularly, we'll be talking about what is IoT, what all things are around. So basically, our session will be having having about like what is basically Internet of Things. Like basically, when you look around, almost everything you see can potentially become part of IoT. Your watch, your fridge, the traffic lights, outside, even a pet, even a pet with a sensor on its collar is IoT. So IoT is about making these everyday things uh, yeah, making things smarter and like to by allowing them to sense, communicate, and act. So for like this session, we will be basically covering the things which will be covering how IoT was termed, like how all things happened, what was the basic idea behind it, like what made people do IoT and how was it implemented, like what all things happened, and then we'll learn about basic things in IoT. Then we'll look for its basic applications in the world where like normal things you see and like normal things you go around are where the IoT is used and what all things can be done. So this is all we'll be covering today. So yeah. So the question arises now, like what exactly is IoT? So IoT stands for Internet of Things, but let's break that down. So the internet part, it's the network that connects computer, phones, and servers. But things, that's the exciting part. So these are the everyday physical objects that weren't traditionally connected to the internet. When you put them together, IoT is a network of connected devices, and these devices, all three abilities, they can sense, they can communicate, they can act. So think of an IoT like giving everyday objects a voice, a light bulb that tells you it's about to burn out, a plant pot that sends a notification to your phone saying, "Hey, I'm thirsty, please give me water," or like in simpler words, IoT links physical and the digital. The physical object still exists. It's a bulb, it's a pot, or even a fridge. But now you have a digital twin to it, a way of communicating it to a wider system. That connection is what makes IoT powerful. So so now next. So yeah, the question arises like why does IoT even matter? Why are companies, governments, or even homes investing in it? Like everyone nowadays are like, I want a smart fan which works on remote control or works on my phone. I want a smart light. I want smart things. So why do you need that? So there are three big reasons for that. First one is efficiency. Second is intelligence, and third is the quality of life. First, efficiency through automation. So let's imagine a factory machine that can detect when it's overheating and stops itself before breaking down. So that saves thousands of rupees in downtime. So also imagine a smart irrigation system where, as I said, if a plant is thirsty, if it could talk. So similarly, if the water crop, you have to water the crop only when the soil is dry. So just imagine how much water will be saved. There would be no wastage of water henceforth. So this is nothing but efficient. So second is IoT gives us smarter decisions with data. Like for example, a city monitoring traffic congestion. So with sensors on the road. So like instead of using the fixed timers for the signals which we see in daily life, so you have a green signal for particular time, red signal for particular time. So basically not having that for like the fixed timers, rather than changing the lights dynamically based on the live data. Like there is more congestion, so we should leave the traffic ahead. So we turn on the green signal, or like there's lesser traffic, so we'll turn on the red light for now. So that would help in reducing jams. It would also eventually save the fuel and all. And then it comes to the improving of quality of life. So basically, how IoT improves our quality of life is basically, now we could consider a great example, that is our smartwatch. So nowadays we see lots of people and number of people use smartwatch, like which continuously monitors your heart rate, and like if your heart rate is above a certain limit, it would alert you for like you need to go and visit your doctor, or like it is a checkup time. You can set time alarms on your watch. You can see, check how much you kilometers you have done the running today, or what distance you have covered for a walk. So this is how it helps us. That's basically nothing but it like helps in saving our lives. Or like at home, you keep the thermostats. So basically the thermostats would do certain things, like it would monitor your temperature and keep you like basically comfortable, while it could save the electricity. So unnecessarily switching on the ACs or the heaters would be just costing you more electricity, rather than when the temperature drops or the temperature increases, turning on the devices would be much more efficient and would help you in saving electricity. So basically IoT isn't just like a tech sake. It's about making things run better, making us smarter, and making our lives safer and more comfortable. So that's the main reason why IoT matters. Now, coming to history of IoT. So as you can see, a beautiful timeline here. So that's exactly how the journey started for IoT. So IoT, so the term, the like it was basically like chapters of a web series or something, like how it grew from one point to another. So in 1980s, researchers were like experimenting with connected machines, which was basically a Coca-Cola vending machines. It was at the CMU, the Carnegie Mellon University. So students connected it to internet to just check if the machine had the cold drinks before walking to it. So this was like basically the simplest form of IoT for solving a small but yet a practical problem. So you don't have to always go towards the machine and check if you have the cold drinks left or not. It was just you could just pop up and understand what if it had the things or not. And in the 90s, the basic term, that was the Internet of Things, was termed by Kevin Ashton, a British researcher at MIT. So he was working on supply chain management with RFID tags, and he imagined a world where every object could be tracked and monitored digitally. So there was the phrase. So basically, the Internet of Things phrase was born then at that. And then in 2000, this like things just took off. RFID became like literal widespread. Sensors became cheaper, and wireless internet grew rapidly. So suddenly IoT was possible not just in labs but in real world industries as well. And like today, IoT is completely mainstream. We are talking about like billions of devices worldwide. So like basically from smartwatches on our wrist to industrial sensors, like in big oil rigs, like from connected cars to like smart street lights and all. IoT has grown from a Coke machine experiment to a technology shaping future, almost like a future of every industry. So talking about the growth, like we saw this timeline particular we saw. So now let's talk about IoT's growth. So talking about IoT's growth, so there is a fun fact that IoT is not just growing, it's actually absolutely exploding. Because like back as the stats we look into, so it stayed like back in 2010, so we had almost about 12 billion connected devices. By 2020, the number grew by that actually doubled to more than 25 billion. And the predictions nowadays are being said for till 2030. So experts predict over 75 billion IoT device would be into the world. So to put that in perspective, that's nearly 10 IoT device for every single person on the planet. And here's what's important. IoT has moved from being niche to mainstream. It used to be seen as futuristic, something for labs or big corporations. But today, it's in our homes, on our wrist, in our cars, in hospitals, and even farms. The fact that IoT devices are becoming cheaper and networks faster means that adoption is accelerating. Just like smartphones went from luxury to necessity in a decade. IoT is following the same path. So, like we can say, like, in even if we won't even think of devices as IoT devices, they'll just be normal. Like, we can't even think about devices to be normal in future. It would be always normal. It would be just an IoT device. So yeah. So now, talking about IoT's architecture. So now we'll go jump into some technical IoT things. So this is the structure of IoT, architecture of IoT. So architecture of IoT consists of four layers: the perception layer, the network layer, the cloud layer, which is basically the processing layer, and the application layer. So to understand how IoT actually works, we need to look at its architecture, the way it is structured in layers. So think of a IoT as a system similar to a human body. We humans have senses, a nervous system, a brain, and finally the actions. IoT has something which is very similar. The first is the perception layer. So this is like our senses. They are like our senses. So this includes sensors, RFID tags, like devices, cameras, which collect the raw data from environment and they tell system what's happening in the real world, just like our eyes, ears do. Second comes the network layer. This is like our nervous system. It basically what it does, it's what carries the information from sensors to where it needs to go through Wi-Fi, Bluetooth, Zigbee, 5G, or other communication technologies. Then comes the processing layer or the cloud layer. So this is like the brain. It takes the raw information, it processes it, it analyzes it, and makes sense of it. Sometimes this happens in the cloud, sometimes closer to the device in what we call edge computing, on which will come in further slide. So yeah. So and finally comes the application layer. It is like our behavior, whatever we sense, whatever we understand, and then the action that we take similarly. So it's where the decisions are turned into actions and where human interact with the system. For example, you might get a mobile notification or a machine might automatically adjust itself. So this is how the architecture has been divided. So talking about every point in detail, here comes the perception layer. So let's just zoom into the layers. So now we'll zoom into the first layer. So this is the foundation of IoT, the part that actually connects to the physical world. It has three main elements: sensors, RFIDs, actuators. Sensor captures the information from the environment. Temperature sensor tell us if it's hot or cold. Motion sensor detects motion. GPS sensor track location. Just like our five senses, IoT sensors allow the devices to feel the world around them. RFID tags are used to identify and track the objects. Like, let's think of them as a smart barcodes that can communicate. So they're used everywhere, like from tracking the goods in warehouses to preventing shoplifting and all. So that- and then there are actuators. So while sensors gather information, actuators do the opposite. They take action. They might turn on a fan, move a robotic arm, or switch on a light. If sensor are the eyes and ears, actuators are like the muscles of IoT. So together, this all elements make the perception layer, and that is basically the foundation of IoT. Without this, we can term it like the system would be literally blind or powerless. So coming to the next layer, that is the network layer. So now, once the raw data is collected, it has to go to somewhere, right? It just can't stay raw, it has to go somewhere. So that's where the network layer comes into the picture. Like, think of it as a highway system for IoT. The job of this layer is to transmit sensor data to other devices or to the cloud. Depending on the use case, it uses different types of communication technologies. For homes, we often use Wi-Fi or for high bandwidth, and Bluetooth for short range communication. For smart bulbs or home security, Zigbee is common because it's low power and works in a mesh network. For industrial application, we might use 5G, which gives ultra low latency and can handle massive numbers of devices. So the network layer is really the core of connectivity. Without it, sensors would just collect the data and keep it to themselves. But with it, IoT becomes a living, talking system where everything shares information in real time. So now we saw the sensing of data and then the transmission of data or the transport of data. But now the next step. So that is nothing but the processing layer or the cloud. So now moving on to the processing layer. So which is basically the brain of IoT. So this layer stores and analyzes data, converting raw signals into meaningful insights. Like think of a heart rate monitor. The sensor collects beats per minute, but that number alone means nothing useless. Nothing you unless it's processed to detect whether your heart rate is normal, too high, or it's very low. So there are two main ways processing happens. One is through the cloud, big like which is big powerful servers that analyze massive amount of data. The other is through edge computing, which means doing some of the processing right next to the device. Like edge compute basically real time. Edge computing reduces delays, which is critical for real time decision like self driving cars or factory robots. So in processing layer, IoT becomes intelligent. So it's not just about sensing; it's about tuning raw data into actionable insights. So now once the data has been tuned, like the data is sensed, the data is transmitted, what action is to be taken is understood. Then comes the step that is application layer. So now talking about the application layer, which is the last layer in the architecture. So that part that we human actually see and interact with. So our application layer is something which the humans actually see it and like interact with what is happening. So this layer provides the interface of for the users. So it could be a smartphone app that controls your smart light, a hospital dashboard showing patients' vitals, or a smart city control center monitoring the traffic. This this is also where IoT touches industries directly, like smart homes that adjust lighting and heating automatically, smart cities that optimize traffic and waste management, or healthcare system that monitors patients remotely. It's at this layer that IoT really creates a value. So the earlier layers were like sensing, transmitting, processing. They are invisible to most of the people, but application layer is something which is where the benefits become tangible, where people see IoT not as technology but real solution, making their lives easier, safer, and better. So yeah, this is how we can say. So now uh, we will summarize this architecture. So IoT is nothing but a layered system like our body, where we can say the senses, nerves, brain, and muscles all work together, forming a collective system. So this is basically a very short example which can walk you through the four layers of architecture of IoT. So jumping on to next slide, that is now that as we studied IoT is layered. So let's look at who makes IoT possible. So basically the providers. There are four types of providers: hardware makers, cloud service providers, platform companies, and connectivity uh, providers. So this on the slide you can see lots of names of lots of companies So among them, they these companies are the mix of all the providers, four types of providers that I just mentioned you. So now some of the biggest name that you can see are like AWS, that is Amazon Web Services, Microsoft Azure, Google Cloud, IBM Watson, Cisco. And so these are some of the bigger companies which play a specific role in IoT ecosystem. So the important point is that IoT doesn't exist in isolation. It's not just about one device or one app. It's an ecosystem, and providers are the backbone that allow IoT system to scale up and actually work in the real world. So talking about the providers, so let's get on to one of the provider, that is AWS IoT. So basically that is the Amazon Web Service. So it is one of the biggest players in is Amazon Web Service in IoT. Like as you see in this particular image, so AWS IoT provides a secure cloud environment where like billions of devices, IoT devices, can connect and communicate. It focuses on scalable cloud services. You can start with few devices and expand it to millions with changing platform. It also provides a secure device management, is meant which means you can update, authenticate, monitor devices over there. Like you don't need to go and do the wired connection and do certain things. And since it integrates with AWS artificial intelligence and machine learning tools, you can do predictive maintenance, anomaly detection, and more. So in short, AWS IoT is like the central nervous system for many IoT projects, handling scale, security, and even intelligence. So jumping to next next IoT provider, that is the Google Cloud IoT. So Google Cloud IoT is one of the most common cloud platform services which most of the guys come to know, because like we see normally the Google Cloud platform, that is GCP and all. So let's just talk about what it is. So Google, as you might expect, it plays to like its strengths and all. So the strengths, basic strengths of Google are the data and AI. In the diagram shown here, you can see how Google Cloud IoT focuses on big data analytics, collecting huge volumes of IoT data and analyzing it in real time. So it offers a strong machine learning tools as well, which help in areas like image recognition from IoT cameras or anomaly detection in industrial sensors. The focus is on real-time insights, turning IoT data into decisions quickly. Like for example, a connected car can send live data to Google Cloud, which processes it instantly to optimize navigation or detect safety issues. So Google's edge is in harnessing massive amounts of data and extracting intelligence, something it has mastered from its experience with search and ads. So yeah. So coming to edge computing. So edge computing, now up to now we have like mostly talked about cloud platforms, but IoT doesn't always wait for the cloud. Sometimes the decisions need to be made instantly. That's where the edge computing providers come in the picture. So on this slide, you can see the logo of you can see the Cisco, HPE, Nvidia. These all are the leaders in the edge computing. So the idea is that instead of sending every piece of data to the cloud, IoT devices can process data locally right at the edge of the network. This reduces latency, the delay between sensing something and acting on it. Like for example, like mm, I think you can think of a self-driving car. It can't wait for cloud servers to process sensor data and then tell it to brake. That delay would be certainly dangerous. So instead of that, edge computing processes that the data inside the car itself will will make sure or will ensure the instant decision that to be made. So if your speed is too fast and if some object comes in between and you have to brake, so that decision could be made by the edge computing. So that's how it should work. So edge providers are critical for the real time IoT applications. Like For example, autonomous vehicles, let's say industrial robots, and let's say smart grids. So, like IoT providers, as we see, so different providers specialize in different strengths. Some in cloud, some in scalability, others in AI intelligence, others in edge computing. So the basic thing is there is like the we can't comment on there is this is the best provider for you. No, there is no single best provider. The choice depends entirely on the use case, like where you are using this, like what is your use case, what are your thoughts behind it, and how you'll be implementing it and all. If you need a massive scale and global connectivity, AWS might be the right choice. If you want a deep enterprise integration, Azure fits well. If you focused on AI, IBM Watson would do better. If you need ultra low latency edge providers like Cisco or Nvidia would be essential. It's just important is and just as important like ecosystem partnerships do matter. So many IoT solutions combine services from multiple providers to get a best of all. Because after all, the main goal is you have to create a better system or the best system. So it doesn't matter you solely depend on one or the service provider or like to a multiple providers. It really doesn't matter unless until you're using it and you have the use cases fulfilled with. So coming to messaging protocols. So messaging protocols. So without messaging, like without communication, like there would be nothing be done among the devices. So for that, like considering that, so now if we get like the most critical thing in IoT is is the messaging protocol. So you can see like devices. So the sensors where and all the sensors have to communicate with the servers and each other to provide the data and to do certain like sensing the data and then providing the data to the brain. So IoT devices need to talk constantly. So billions of small messages, like for example temperature reading, GPS coordinates, machine vibrations and all are constantly being sent to the brain, sent to the devices, like every time, every second, every moment it is being sent. But like here's the challenge, like there are traditional protocols like HTTP which are too heavy. So imagine trying to send postcards through a cargo truck. So it is basically a overkill, right? So you don't require that much of amount to be sent from a bigger container, or which will be more expensive and which is insufficient. So that's why IoT relies on lightweight protocols, specialized methods that are efficient, fast, and designed for low power devices. So now we'll be exploring certain protocols in next few slides, so which I will walk you through. So let's start with MQTT. MQTT is the full form is message queuing telemetry transport. So you see on the picture you see, so there is something known as publish subscribe. So this is nothing but a publish subscribe model. So devices don't talk to each other directly. Instead, they send messages to the broker. The broker then distributes the message to subscriber, like who is interested. So let's consider there are n number of devices. So a device that wants to understand what is the certain thing, it will take the data from that and then reply to it. So now, Mm, breaking this down into a simpler example, let's just think about a post office. So you don't deliver letters to your friends individually, right? You drop them at a post office. So if your friend has subscribed to the post office, so the post office delivers the letters to them. The post office is basically the MQTT broker. So okay, so now the question comes, why MQTT is like so popular? So the thing is because it's lightweight and reliable. It works even in poor network condition and consumes very little power. The perfect for IoT devices that need to run on smaller batteries. Like that. That's why MQTT is the backbone of like many smart home systems. like connected cars and or even industrial IoT projects. So coming to the next protocol, that is CoAP. CoAP stands for Constant Application Protocol. So in this you see something like the two server in the picture you can see servers so throwing HTTP to client proxy, and the CoAPs are connected. So basically CoAP is basically like HTTP but designed for the IoT devices with limited power and memory. So let's consider HTTP as a delivery van. It's powerful, it can carry a lot, but not ideal for tiny narrow lanes, right? But CoAP is like a bicycle courier, small, nimble, and perfect for lightweight deliveries. So CoAP is a REST-based that means it uses familiar operations like get, post, put, and delete. So, like for example, a smart bulb might respond to get request saying the status is if the bulb is on, the status is on. So, if you send a post request, the bulb might switch off. Like if you send it a post request of like turn it off, turn off, or anything, so it might switch off. So it is commonly used in constant environments. So, like battery powered devices, like small sensors, or in a low bandwidth network. CoAP is essentially a miniature version of a web designed for tiny IoT devices. So coming to the next protocol, this is AMQP. AMQP is nothing but advanced queuing, message queuing protocol. So we can like now we can in this particular picture we can see that there are multiple devices connecting through a structured system with like acknowledgements and receipts being exchanged. So if so now putting it straight, so there are some common terms like publisher, consumer, which we saw like in MQTT, which was publish, subscribe basically. So now putting that, considering that, so if we consider MQTT as a local postman, AMQP is like international courier service like FedEx or DHL. It doesn't just deliver your package. It tracks the package. It confirms the delivery. It guarantees the reliability. That that's why AMQP is heavier compared to protocols like MQTT or CoAP. It requires more bandwidth and power, so it's not suitable for tiny sensors or battery powered devices. But it is good in enterprise grade application like where reliability is critical, like banking systems, financial transaction. So let's consider an example of stock exchange where even small message loss can cost you m- like millions of rupees. So AMQP provides the robust guarantees where the instant reliability and the instant things are being done. So it it has a strong security feature, making it trusted in mission critical environment. So while it's not for like every IoT project or like AMQP is the go-to protocol when the guaranteed delivery and enterprise reliability are non-negotiable, as I explained you with the example of a stock exchange. So yeah, coming to the next protocol, so HTTP and HTTPS. So it is one of the most famous and at like old protocol, that is HTTP and HTTPS. So HTTP stands for Hypertext Transfer Protocol. HTTPS stands for Hypertext Transfer Protocol Secure. So HTTP is most widely supported protocol in the world. Every browser, every server, every developer already knows it. So that's why many IoT devices also rely on it. It's easy to use uh, and universally compatible. However, HTTP is resource heavy. It consumes more bandwidth and more energy. For small IoT devices running on batteries, this isn't practical. But for larger, more powerful devices like smart TVs, connected cars, or industrial machines, HTTP is perfectly fine. The big advantage is security. HTTP ensures encrypted communication, protecting sensitive IoT data from hackers. So HTTP is like basically a highway. It's built for large vehicles, not bicycle. It works, but it's not always the most efficient choice for smaller IoT sensors. So now let's break all the breaking all the four protocol that we saw into a table with a comparison. So that's how we can compare it. So the comparison we can see is like we can just put all the protocols like side by side, and we can finally comment on it like MQTT is a lightweight protocol which is scalable and great for unreliable networks. Like it is a friendly neighborhood postman, like a fast, efficient, and low cost. COIP is a REST based protocol, REST based, like perfect for constrained devices. It like the example I mentioned, a bicycle courier which gets through the small lanes quickly. AMQP is reliable, but again, on the same point, it's heavy. It's suited for enterprise grade use, like but like not used for the smaller ones, smaller IoT devices. So as I mentioned again, the example it's like an international courier device, the FedEx or DHL. It guarantees delivery and with receipts, and like it tracks the delivery. HTTP, it is universal but resource hungry, like a highway system that works for everything but isn't always efficient. Again, coming back to the choice of the protocol, so that there is not always one particular fit for all. The choice literally always depends on the factors like power, bandwidth, reliability, and the scale. So that's how you go and you choose it. So now basically different devices from like tiny sensors to industrial machines all use different protocols based on their needs. There is no basically one particular protocol in IoT. Every choice is basically a trade-off between power consumption or reliability or scalability. If you are building a battery-powered sensor for agriculture, MQTT or COAP is a better choice. If you are handling enterprise transactions, AMQP is safer option. And if you have powerful devices with plenty of bandwidth, HTTP or HTTPS still work. So basically, as per your use cases, it is better to understand your use case and pick the right tool for your job. Like basically, protocols are just like language, and IoT device need to that speak the one which best suits them. So which helps them to understand more better understanding better and making the system better, which would by default make your IoT project or a IoT device better in various cases. So now, after protocol, we'll take a look at what are the IoT use cases, which is one of the most important. Like where is IoT basically used? So now that we have covered architecture, the providers, the messaging protocols, so now we'll come to the use cases. So now, as you can see, there are various pictures mentioned in it: smart factory, industrial devices, smart grid, energy savings, cost reduction, smart traffic, agriculture, smart cities, medical devices, smart homes. These are all where the things are been IoT is been implemented and it is been used all over. So now considering a smart home where light, appliances, assistants like Alexa or Google Home are used. Healthcare monitoring is like where your wearable devices such as heart rate monitoring from your watch and all are being used. Industrial IoT, often called as IIoT, where factories use sensors, automation to boost efficiency. Smart cities, IoT used for traffic management, waste reduction, or public safety. Agriculture is where for optimizing irrigation, monitoring crops, track life, track livestock, and various other applications. So basically, IoT is not just limited to technology companies. It is a universal enabler. So no matter what field you are in, IoT has got a role to play in it. So talking about the use cases, we'll jump to the use cases and we'll briefly see them. So let's just start with the smart home, which is quite familiar with you guys. So smart home is like you can see lots of devices connected inside a home, like voice assistant, smart appliances, and automated lighting. Now think about how you live today. Maybe you already use Alexa, Google Home. You have the Google Assistant on your phone. Similar way, so voice assistants are at the center of many smart homes. They connect and control devices using voice commands. Like smart appliances like refrigerators that tell you when the milk is running low, or washing machine you can start from your phone. These things are becoming very common nowadays. And then there's energy efficiency, like smart thermostat, like Nest Learn, like basically which helps you automatically adjust the heating or the cooling to save the power. So in smart homes, IoT isn't just about convenience; it's about saving resources, lowering cost, and creating comfort as well. Now coming to next is the smart city. So as I told you, like one big application of the smart traffic management, the traditional traffic light run on a fixed timer, but IoT enabled traffic system can adjust signals dynamically based on real time congestion. For example, in cities like Singapore, sensor track car flow and adjust signals to reduce the jam. Another example is waste optimization. Imagine garbage bins with sensor that notify the municipality only when they're full. Instead of trucks following the fixed routes and wasting fuel, they're dispatched only when the need. So this usually saves the cost and reduces the pollution. Then we can talk about the public system, safety system. So basically, public in that use of IoT could be for surveillance, emergency response, and even disaster management. Camera, sound sensors, flood monitors, all work together to keep the citizens safe. So smart cities are uh, essentially living organisms using IoT as the nervous system to improve the efficiency, sustainability, and safety for millions of people. So talking about the healthcare. So as I told you, so healthcare in healthcare, the most familiar example is the wearables. Smartwatches today can track your health rates, sleep patterns, oxygen level, even ECGs. So this device act like a mini health assistant strapped with your breast, your shoulder, or your arm, even your wrist. So this is and when something goes wrong, like IoT enables the emergency alert. A fall detection device worn by a elderly patient can instantly alert caregivers or the family. So during COVID-19, IoT played a massive role in enabling telemedicine and keeping patients monitored safely at home. So this was where the IoT healthcare IoT was implemented more quicker. So in healthcare, IoT is not just about convenience, it's about saving the lives. Jumping to industrial IoT. Industrial IoT, so now you can see machines with sensors, the robots working side by side with the humans and and the dashboards which show the live data. So one of the most famous applications is predictive maintenance. Instead of waiting for a machine to break down, sensor monitors its health, vibration, temperature, energy usage, and predict failures before they happen. This reduces downtime and saves huge costs. Then there's robotics and automation. IoT allows robots and machines to coordinate with each other, making factories more flexible and productive. And of course, safety monitoring. Sensors detect hazardous conditions like gas leaks, excessive heat, or unsafe human behavior, and trigger immediate alerts. This part is what we call Industry 4.0, the fourth industrial revolution, where IoT, AI, robotics merge to create intelligent and self-adjusting factories. So next application is agriculture, IoT in agriculture. So IoT in agriculture. So let's consider smart irrigation. Smart irrigation is one of the biggest breakthroughs. Instead of relying on guesswork, IoT sensor measures soil moisture and trigger irrigation automatically. This ensures crops get exactly the water they need, reducing waste. Then there's soil and crop monitoring. Drones equipped with cameras and sensors can scan entire fields, detecting plant health, pest attacks, or nutrient deficiencies. Finally, livestock tracking. Smart collars on cows, for example, monitor movement, eating habits, and even body temperature. Farmer get alerts if animal is sick or lost. So, like in agriculture, it makes the farming smarter, more sustainable, and more profitable. Now, coming to environmental monitoring. So, environmental monitoring, the basic uh, users are like air quality sensors. They measure pollution levels in real time and share the data with the public. This helps people avoid exposure during high smog days or like pressure governments to act. Water monitoring. It ensures clean water supplies. IoT sensor detect contamination in rivers, lake, and even pipelines. So, like in India, for example, IoT projects are used to monitor the Ganga river's population level, where they monitor what is the amount of pollution, what is the amount of uh, impurities in the Ganga river. And perhaps most importantly, IoT aids in like disaster prediction. Flood sensors in drain, earthquake early warning systems, and wildfire detector can provide critical alerts before disaster strikes, giving people time to react. So reality and supply chain. So the smart shelves in store which use weight sensors or RFID tags to know exactly when a product is running low. Imagine walking into a store, like never seeing an empty shelf because the system automatically alerts the staff to restock or even places the orders by itself. So inventory management becomes very much smarter with IoT. Like instead of manual counting, RFID tags track goods across warehouses and during transportation. Like companies like Walmart, Amazon heavily rely on the IoT to streamline the logistics. Then then comes the cold chain tracking. This is a critical products like vaccine, food, or medicine that must stay at specific temperature. IoT sensors in the storage unit monitor temperature continuously. If there is a deviation, alerts are sent immediately. So in the retail and supply chain, IoT ensures efficiency, transparency, reliability from one warehouse to literally your shopping bag. Then comes the transportation and logistics. So, like one of the biggest application is the fleet tracking. So, fleet tracking is nothing but using a GPS-enabled IoT device. Companies monitor the location, speed, the condition of vehicle in real time. This helps ensure time delivers and reduces the theft. Next comes the route optimization. IoT systems can analyze the traffic, weather, road condition to suggest the most efficient routes. This saves fuel, reduces delivery times, and improves customer satisfaction. And then comes the vehicle to vehicle communication, that is V2V. So imagine a truck is in a convoy automatically coordinating speed and braking through IoT. This would make highways more safer and more efficient and more free for like which would heavily reduce the congestion or the traffic congestion on the smaller roads where the big vehicles usually travel. Now, talking about the wearables, so most common is the fitness tracking devices. The famous fitness band was the Fitbit or the MI band, which tracks the steps, the calories burned, and the workouts. They have made like personal health monitoring mainstream, where you can get to know everything that you need, like the calories burned and stuff from that. Then comes your the smartwatches and smartwatches in IoT, where you can be using it for the using smartwatches, basically using them to monitor your particular activity, which would help you grow into that activity or improve that. That is where IoT is becoming a part of daily life, like which blending convenience with health and productivity. So talking about the smart energy now. So smart energy is like basically we can use like the smart meters, grid monitoring, renewable integration. Then talking again about the smart factories, so the IoT system will have the automation plus robotics, the digital twins, and the productivity gains. Talking about connected vehicles, so connected vehicles, as I said, the V2X communication or the V2V communication, where two or more tracks or the trucks are being connected with one or the other, so to reduce the congestion on the highways or to reduce them and make it more efficient and make it more faster and quicker. So that's how the connected vehicles would work. So like basic challenges that you face in the IoT are like the security vulnerabilities, scalability issues, the interoperability gaps, and the power on the energy limits. So these are the challenges that are currently faced in IoT. As everything has a pros and cons. Similarly, IoT also has certain challenges, and these are some one of the most common challenges that are being faced in IoT. So like upcoming, like we're talking about the future trends. So the future trends are like AI and IoT integration. So talking about them, so talking about the future trends. So as we saw, so the future trend like the AI and IoT integration, we that is the newer trend that could be the future trend that has been heavily emphasized in IoT nowadays. So and then coming back to the 5G, the second is the 5G and beyond with the ultra fast and low latency networks. Like IoT will expand into new areas like autonomous car, which are autonomous cars, AR, VRs, and like IoT enabled robots powered by 5G. Then is the digital twins. So the virtual replicas of physical system, like an entire factory can have a digital twin where managers simulate changes before applying them in real life. This saves money and also improves the safety and increases the efficiency. Then we can talk about like sustainable IoT. Devices are designed to consume lesser energy and integrate with renewable power resources. So the future of IoT is not just about more devices, it's about smarter, faster, and greener devices that transform the daily life. So, yeah. So this is the basic talk on IoT. So I would like to ask you if you have any questions, you can just add it in the chat so that I can hopefully answer them. Yeah, guys, any questions? Okay, so I'll share you a quiz link. So it would be like you have to solve the quiz so that like we can understand like what is the how the session and all was like for you. So I request you guys to kindly solve the quiz. So this is the form link that I've shared in the chat. You can access it and solve the quiz. You have 5 minutes for the quiz. After that, the quiz will be off.